and that's just not.
Mr. Mines was on.
We are recording. Let the recording begin. A sequence K starts 12:6. Whoops. If you know the sequence is arithmetic, write a recursive definition for this sequence. It's arithmetic means what?
It's
Adding or subtracting the same number. So what are we doing here?
A of n equals A,
wait.
parentheses n minus 1, subtract 6.
Wow.
Y'all,
Period.
that's the most painless thing we've ever done. Would you not agree with that?
I like recursive.
So would the next one be, you can't, on the next one, can we use recursive again, or do you have to use geometry?
Well, this one says write an equation for the nth term knowing it's geometric,
Explicit.
Okay.
right? So this one's not a recursive definition. This one was a recursive definition, that's why we used the previous term. This one's the nth term, so we're going back to this rule for geometric.
And it starts at 12, and then, wait. And it doesn't start at 0.
So you tell me what it starts with, because it really
So
doesn't.
A of n
A of n?
equals, would it be 12?
That's the first term, right?
Times, I know, yeah,
12
times,
times 0.5
yeah. And then the nth on
to
the top.
And that's if a of 0 is 12, right?
Yeah.
Because we use the n when we start with the 0 term, right?
Oh, shoot, so we did it wrong.
No, you didn't do it wrong. Because it didn't tell us what n started with.
Yeah.
Once you say this, you've declared what it starts with. You're telling me the first term is 12. So if I plugged in 0 for n, I would get 12 times 0.5 to the 0 power. And that would be 12, it would be correct. And if I plugged in 1, it would give me 6, and that would be correct.
Can I do the next one? Because I know this.
Oh, you know the next one?
Yes, it's geometric.
All right. A sequence A begins 1, 7. Write a recursive definition. I'm going to underline that because that's important. For the sequence using the function notation if the sequence is geometric. That's important too. So, okay. Who's doing this one? Help me out.
Okay, it's going to be A of n
A of n.
equals A parentheses n minus 1 times 7. Correct?
Previous term times 7 if it's geometric.
Yeah.
But we multiply 1 times 7 to get 7, right? This is so much fun. Now we're going to write an equation for the nth term if the sequence is arithmetic.
But it's not.
Well,
Yes, if you
in
can,
part,
okay.
yeah, we don't know. We didn't know. This is saying if it was, then how are we changing these time now?
It's plus 6.
So we're going back to these rules.
And it starts at 1.
You want to start at 1?
It does start at 1.
Okay, so but what I'm saying is you're in. Do you want A of 1 to equal 1 or do you want A of 0 to equal 1?
And, wait, do I want A of 1 to equal 1?
Yes. If you did, then we would be starting the sequence with n
Okay,
equal 1.
I got it.
I want n to equal 1, because n does equal
A of n, A of
A
1.
of n.
How about this? A of 1 equals 1. A of 1 equals 1.
1. Good.
All right?
Okay.
So
A of n
A of n,
E equals
equals 1
that's their initial term, right?
plus
6.
6 to the n.
Times
n subtract 1.
n minus 1 because you started with n equals 1.
Do you mind scooting it down? The recording's in the line.
Sorry, yep.
Thank you.
Wasn't that fun?
I like recursive better. Can we just like have a whole unit about recursive? Like I would have.
A whole unit of recursive.
Yeah.
We'll have so many more fun. Well, the nth term, what they're calling the nth term is the explicit, is what I call it explicit. And what IXL called the
Oh, it's
explicit.
the same thing?
Yeah, they're the same thing.
Oh.
Wait, what is?
The nth term rules.
And explicit's the
You're
same thing.
joking.
No, I'm not joking.
So this whole time we've been doing explicit.
We've been doing it, having fun.
Okay, well, I'm stupid.
No, you're not stupid.
You're smart. Don't ever say that about yourself.
How about this one? How about this one? A sequence is defined by f of 0. So what are we starting with? N equals 0 or n equals 1?
N equals 0.
All right, so we know when we go to rules, the n equals 0 rules, what we're going to do. It starts with f of 0 equals -4. And it's giving us, what kind of definition is this?
This is gonna be a recursive.
It's giving us,
Arithmetic.
it's giving us recursive definition, arithmetic, because it's subtracting 2 each time, right?
Yes.
So let's look at this sequence a little bit. When n equals 0, f of n is going to equal what?
-4.
Negative 4. So when n equals 1, what would f of n be?
-8.
Is it multiplying or subtracting?
Oh, I thought we had a rule already. I'll just get some around.
Eat 'em.
It would be -2.
If you did negative 4 minus 2,
-6.
negative 6. There you go. What would f of 2 be?
-8.
And then we just keep going, wouldn't we? What's the next one? It just keeps going down by 2 each time, right?
Did you have to put that?
Right. Okay, listen, you didn't have to do that, I didn't ask you, but it'll help you if you get used to seeing what the sequence looks like. Because now, what we're gonna do is write a definition for the nth term of the sequence. Okay? We started with n equals 0, so we said it's arithmetic, so we're going back to this rule, right? Let's see if I can get that rule in there where y'all can see it. How about that? So help me out with a rule for f of n.
F of n equals,
Wait, -4. Oh,
That's your first term, right?
yep.
yeah.
Minus 2, it's arithmetic, so we're not going to the nth power, but we start with 0, so we're going to times n, right?
Yeah.
And that's it. And we're at another 7-minute video. We got this timed about perfect, don't we?